Peter, I have watched this application slowly choke until it dies a silent death. Why do memory leaks never stay small, but instead grow into resource-devouring monsters that eventually crash everything?
That is a great question, Stewie. You should stay tuned until the end to learn how to spot these silent killers before they ruin your weekend. At its core, a memory leak is like a leaky faucet in a house with no drains. Most programs allocate memory on the heap for temporary tasks, but if the code forgets to release that memory, it stays reserved forever. As the program continues to run and perform more operations, it keeps grabbing new chunks of RAM while never letting go of the old ones. In a high-traffic environment like a Kubernetes cluster, this accumulation is exponential because the leak happens every single time a specific function is called.
But Peter, I thought modern languages had garbage collectors to clean up after themselves. Are they simply lazy?
They do their best, but garbage collectors are not psychic. A leak usually happens because your code is still holding a reference to an object that it no longer needs. For instance, if you add items to a global list or a cache but never remove them, the garbage collector thinks they are still important. This is common in Node.js applications where event listeners are added but never cleaned up. Pro tip: use tools like Valgrind or the Chrome Memory Profiler to look for objects that persist across multiple garbage collection cycles. You are looking for a staircase pattern in your memory graph instead of a healthy sawtooth pattern.
So the memory just keeps piling up until the system finally decides to pull the plug on the whole operation?
Exactly. Eventually, the operating system runs out of physical RAM and swaps space. When that happens, the out-of-memory killer, or OOM killer, starts terminating processes to save the kernel. It is a compounding problem because as memory gets tight, the CPU spends more time trying to find free blocks and running the garbage collector more frequently, which slows everything down. This is why performance degrades long before the crash happens. If you want to master the art of writing efficient code and avoid these disasters, make sure to like and subscribe for more deep dives.